What are structural cracks? According to the ACI concrete terminology, crack is the complete or incomplete separation of either concrete or masonry into two or more parts. These are usually produced when a part of the concrete underwent movement which lead to it breaking or developing fractures. In general, a crack makes the concrete and the structure more vulnerable to external effects, accelerates the aging process, and can immediately reduce the mechanical resistance of the structure. What causes structural cracks? Deformation. The forces applied to the structure, tensile, compressive, or shear forces to the concrete. These forces generate deformation, which can lead to cracking. Hydraulic shrinkage. Shrinkage is due to the evaporation of part of the water contained in the concrete. Cracking occurs when shrinkage forces become greater than the strength of the concrete. Thermal shrinkage. Cement hydration is an exothermic reaction producing heat that dissipates over time. The variation of temperature, which is also not equal in all parts of the structure, generates differential deformation, which may lead to cracking. Swelling. Concrete may swell because of salts such as sulfates, which can be contained in the earth in direct contact with the concrete. And corrosion of the steel reinforcement. The rebars may corrode under certain conditions, forming rust. As the volume of corrosion products or rust formed is greater than the volume of the initial rebar, this causes tensile stress on the concrete. In the case of advanced corrosion, the concrete may crack and after some time will delaminate or dilapidate it. What are the effects of cracks? Substances that can penetrate cracks like chloride humidity and the processes that can contribute to the degradation of concrete, such as carbonation. What is carbonation of concrete? The carbonation of concrete, a natural phenomenon, leads to a reduction in the high pH of concrete, which is the reason for the passivation of steel in concrete. Carbonation is accelerated when a crack is opened and can penetrate to the rebars much faster. How can carbonation be mitigated? Using recycled aggregates that come from crushed concrete or masonry from demolished structure and have been known to have higher water absorption. Studies have shown that mixes using recycled aggregate concrete have higher porosity, water requirement, and lower Poisson's ratio. And with the proper water-cement ratio and other performance additives to the mix. Recycled aggregate concrete mixes can perform equally, or in some cases, better to natural aggregate concrete mixes. What is carbonated recycled aggregate concrete? When recycled aggregates were carbonated and densified, a reduction in the water absorption of recycled aggregate concrete was observed. Some experiments have shown promising results in its resistance to carbonation compared to samples that made use of natural aggregate concrete. Results have shown higher density and lesser porosity, which indicates that carbonation treatment of recycled aggregates concrete is an effective method to reduce carbonation depth. What are other ways of optimizing recycled aggregate concrete? To properly enhance the overall performance of recycled aggregate concrete, the use of bio-based self-healing agents have been utilized in multiple ways. Biodeposition or the induction of certain chemicals or microbial elements have proven to be one of the more effective techniques. Results of biodeposition show increased workability by 139%, a higher compressive strength when compared to natural aggregate concrete, and a negligible difference in the density of the sample itself. What are the other benefits of using recycled aggregates? The construction industry alone is responsible for 11% of the world's total carbon emissions. Therefore, the use of innovative ways in minimizing the carbon footprint of a project goes a very long way. Using recycled aggregates serves as an economical material choice in construction and an environmentally friendly way of prolonging use and life cycle of a discarded material. Recycled aggregate concrete, produced with crushed concrete aggregates, has a smaller carbon footprint because it does not require the same energy and natural resources to produce, unlike natural aggregates. The utilization of recycled concrete reduces the seemingly continuous depletion of natural resources needed to manufacture components for fresh concrete.
I'm Esteven John B. Buduan.
And I'm Kieffer R. Camposano.
And I'm Maebeth Guiyab.
And I'm Patricia Monique Rivera.
And I am Franchette Yvonne O. Velasquez.
#Excellence Beyond Limits.